Dear students, in semester C we have op-amp, operational amplifier. We see some basic property of op-amp at the beginning, so it will be helpful for your examination. So first of all, what is op-amp? What is op-amp? So op-amp full form is a operational amplifier. Operational amplifier, and in short you can write op-amp. This is one integrated circuit designed for high gain, and it is of the order of 10 raised to 5, and it performs the operation like summation, integration, differentiation. So it performs the mathematical operation, so the word use operational amplifier. And by using external circuit, it can be used as a filter, it can be used as oscillator, diode tester. There are so many applications, but when this is prepared, at that time the purpose was for this only, to get the summation, integration, differentiation. So this is op-amp. It amplifies both AC as well as DC. It amplifies both the signal AC as well as DC. You know, AC means alternate current and DC is direct current. Okay. If you see, the construction of op-amp, so there are so many transistors. So I taken this figure from operational amplifier by Ramakant Gaikwad. So it is actually made of 4 different blocks that we'll discuss. So first block is a dual input balanced output differential amplifier. So this is amplifier 1. Dual input means 2 input, it has 2 inputs and 2 outputs. So one output is from this transistor and second output from this transistor. So it has 2 output, 2 inputs. So it is called balanced. 2 input, so it is dual. So dual input, balanced output, differential amplifier. This is your first stage. This is your first stage. Now in second stage, one input is here and other input is here. So again it is 2 inputs, it has 2 inputs. So you can say it is dual input. But output is from one transistor only, not from this transistor. So it is unbalanced output. So dual input, unbalanced output, differential amplifier, that is your second stage. Okay. Then whatever you are getting the output at this point is not at ground level. Suppose you are amplifying the signal, So this is your 0. And instead of getting output at 0, you are getting output with some DC component. So suppose this is 5 volt. So you are getting swing around to 5 volt, not around the 0 volt. If you are getting like this, you can say it is ground level. It is at ground level. But we are getting at 5 volt. It means it is not at the ground level. So it is necessary to bring this wave to here. And for that we have this level shifter. And for level shifter, it is known emitter follower is used. So it is totally separate discussion on the emitter follower. At this level, we cannot explain, or I cannot say emitter, what is the function of emitter follower. It is a separate part. If you know the function of emitter follower, then immediately you comes to know that it is used to bring your output at the ground level. So it is level shifter. It is called level shifting stage. And then what you are getting the output here. You cannot use directly to your device. Suppose this is the output, it is already amplified. Suppose you connect with the speaker. Okay, this is your speaker. You connect this point here, and one is grounded. So there is some problem. What is that? There may not be matching. This is not match with this input of this one. So what I want to say that all electronic devices has own resistance. The speaker has own resistance because of the coil, and the coil also. And this coil has own resistance. And this resistance, suppose I say R2, and this resistance here, if you measure between these 2 points, is resistance R1. Okay. So whatever the output is coming over here, suppose I say V in, then what you get the here output is VO. So VO will be equal to, R2 upon R1 plus R2 into V in. This is your voltage divider circuit. You must be knowing this thing. વોલ્ટેજ ડિવાઈડ થાય બે રેઝિસ્ટર છે, અહીંયા R1 છે, R2 છે, તો આપેલા વોલ્ટેજ બે ભાગમાં વેચાઈ જાય, આઉટપુટ વોલ્ટેજ અહીંયા જવાનો છે, જેની એક્રોસ માપવાનું છે R2 upon R1 plus R2 એવું થાય. Okay. So if this R2 is large enough, then whatever the value of R, we don't have any problem. We get whatever we want to supply the voltage, you get at the speaker. But suppose this R2 is not that very large. We don't know what is the resistance here. This is R2. So what happens if R1 is large? Means resistance between these two is large, then what happens? This denominator is large, and so voltage in the speaker will be less. It gives less current. So whatever the here voltage, but it is useless. So we have to minimize this R1. So if you want to minimize the R1, this is not in our hand. We cannot minimize this. So one more block is added here, and it is called output stage, and it is made of what? A complementary symmetry push-pull amplifier. This is push-pull amplifier. One transistor here, other transistor here. So push-pull transistor નું main કામ શું છે? તો એ તમને ઓછામાં ઓછો વોલ્ટેજ રેઝિસ્ટન્સ કરી આપે. તો હવે હું અહીંયાથી જ્યારે અહીંયા સ્પીકર જોડીશ તો આનો રેઝિસ્ટન્સ તો બહુ નાનું છે. આનો રેઝિસ્ટન્સ ઇનપુટ અહીંયાથી માપો તો વધારે હોય, અહીંયાથી માપો તો ઓછો હોય. તો અહીંના વોલ્ટેજ બધા ડિલિવર અહીંયાથી જાય, અને આ એક બફરનું કામ કરે, અને આ વોલ્ટેજ છે થ્રુ પુશ પુલ એમ્પ્લીફાયર ક્યાં જતા રહે? ઇન સ્પીકર. સો વી have no loss. or if it's lost, then it's very less. समझ में आयु? So we need this push-pull amplifier which has very high input resistance and very low output resistance. એટલે જ્યાં આગળ આવું હોય કે કોઈ એવી આઉટપુટ છે જ્યાં આઉટપુટ રેઝિસ્ટન્સ વધારે છે અને એમાંથી આપણે કરંટ ડ્રો કરવો છે, ખેંચવો છે, તો મારી પાસે વચ્ચે શું મૂકવું પડે? બફર મૂકવું પડે. તો ઇટ ઇઝ વેરી સિમિલર કે સપોઝ આઈ હેવ પાઇપલાઇન, ઓકે, and I have another pipeline and I want to join this. So if directly if I join it, then what will happen? There is a leakage. Okay. So whatever the water is coming here, some part of the water is flowing through this small pipe, and there is a wastage of the water. So what we are doing? We are using coupler. આવું કરીએ છીએ ને આપણે. So આ જે coupler નું કામ કોણ કરે છે? push pull amplifier. શું કરે છે? push pull amplifier એ કામ કરી આપે છે. It connects two things. કઈ connect the device which has low input resistance, R2 is less, and a device which has high output resistance. એટલે જેનો આઉટપુટ વધારે હોય અને ઇનપુટ જેનો નાનો હોય એને જોડવાનું કામ કોણ કરે? તો કે push pull amplifier. So this is the fourth block, and this is designed in a single chip. If you go in the market, you can ask for op-amp. So there are different numbers are available. We are using in laboratory 741 IC. 741. T57 is also available, but for laboratory purpose, for understanding, we use 741. So in lab you can use it. There are different types of ICs are available. The IC means op-amps are available. કયા પર્પઝ માટે તમારે યુઝ કરવું છે? કઈ સારી છે, કઈ ખરાબ, એવું નહીં કહેવાનું ક્યારે. All are good. Sometimes cost wise good, sometimes functioning wise good, sometimes temperature range માટે સારું હોય, expensive હોય પણ વધારે high temperature એ કામ કરાવવાનું હોય. તો there is nothing like which one is good and which one is the bad one. જે પર્પઝ માટે બનાવેલી છે એ પર્પઝ કામ આપે, means all are good. Any characteristic મુજબ કામ કરીને આપે, they are good. Okay, so this is the thing. So this is the four blocks. Again I repeat, and so many times this question can be asked also. So I explain the block diagram of op-amp. So if I draw it, then suppose this is my first block. Sorry. Okay, this is my first block. It has two inputs, okay, and two outputs. It is called dual input balanced output. Then we have second block, okay, this is second block, and it has only one output. Again we have one more block. It is called level shifter, emitter follower. In fact, again you have one more block, and that is called output stage. Okay, output stage, and it is made of push pull amplifier. So this is finally you have output. So we have two inputs, two outputs, one in output, one output, and final output. So this is made of dual input unbalanced output, which gives you most of the gain of the op-amp, which provides most of the gain. એમાંનું એક ઇનપુટ છે, કેવું કહેવાય? નોન ઇન્વર્ટિંગ કહેવાય. નોન ઇન્વર્ટિંગ પહેલા બી આવી ગયું છે. નોન ઇન્વર્ટિંગ મીન્સ if you give input here, then we get output in phase. અને જો ઇનપુટ અહીંયા આપું તો આઉટપુટમાં મને કેવું મળે? આઉટ ઓફ ફેઝ મળે. તો depending on that, sometimes this is called positive, this is called negative. Okay, this is called input stage. બનેલું કેનું હોય? તો કે dual input unbalanced output બનેલું હોય. Then intermediate state. intermediate stage. Okay, and એ શું હોય છે તો કે dual input but unbalanced. Sorry, unbalanced. Sorry, unbalanced output. This is balanced output. And then this is called level shifter. Level shifter. કોનું બનેલું હોય તો કે આ બનેલું હોય છે emitter follower. Emitter follower. And then you have output stage. Output stage, and this is push pull. Push pull. And it complementary symmetry word વાપરે push pull amplifier. Okay, so here we get some gain. બાકીનો અહીંયા gain મળશે, અહીંયા level shifting થશે, અને અહીંયા આગળ આપણને output resistance છે એ તમને શું કરી આપે, ઓછો કરી આપે. So this is the block diagram for op-amp. This is block diagram of op-amp. Okay, તો આ ક્વેશ્ચન પૂછાતો હોય છે આ રીતે. Explain it.